Hey, yeah, I still love this stage. So yeah, today we will be talking a bit about web stuff in general. And I've created really catchy title to grab your attention, like Reinventing MVC pattern for what's the F# web programming. That's amazing title. But in short, yeah, that's me again. I'm doing stupid jokes. So yeah, my name is Chris. I'm from Poland. Yeah, I'm doing a bit of open source stuff. I'm doing Ionite. I'm doing the project that I will be talking today about, which is called Saturn. Also, yeah, I'm traveling around the world and speaking in those conferences. And a couple of months ago, on one of those conferences, Philip Carter, where is Philip? Say hi. Say hi to people. Oh, Philip is on the balcony. Called me, give me new official title, which is OSS Troublemaker. Thanks, Philip. Yes, and again, as usually, I have warnings on the beginning of my talks. This is controversial topic because there are a lot of people really opinionated about how web programming should look like and what you should do in web programming, especially in the back-end web programming, and that's something that we will focus on today. And the second warning is I don't know enough about Web Sharper. Probably I should. So I will do some small comparison in part of this talk between what are the problems of some current existing solutions in web programming stack. And I'm not mentioning Web Sharper. Check it out. So why we even talk about web programming in context of F#? And the answer is really simple. The web in really principle is just functional. The HTTP protocol can be modeled as a function. That's a function that takes HTTP request, and then after some time it returns HTTP response. And I've stolen that from Thomas. Where is Thomas? Thomas is also somewhere on balcony. So yeah, thanks to him. And this model, it can be really easily implemented in functional programming languages because, since the HTTP protocol is just a function, this means that probably how whole web server can be treated as a function, which is true to a degree. And there are two great libraries in F# space. First one was Swav. It's been around for years, and it kind of introduced this particular programming model that I will describe in a moment to F# community. And the second one is Giraffe. Giraffe is a newer project, and it takes Swav programming model and puts it into ASP.NET Core MVC. Because Swav essentially is not only a web library, but it's also a web server on its own, which has some problems. And Giraffe, people that created Giraffe decided that they really like programming model, which is cool, but they want to leverage the ASP.NET Core. And that makes sense because Microsoft has been really serious about ASP.NET Core recently. It's like topping all benchmarks on tech benchmark thingy with 6 billion requests per second, whatever, some crazy numbers. So yeah, Giraffe. And I again have problems with Pilot. So the most important thing you need to know about the model is the type called HTTP context. HTTP context contains information about incoming HTTP request. It contains information about current state of HTTP response and has some additional info about web server, about some global state that we may create, if we are so crazy to create global state. But yeah, it has some infos. And then there is something called web part. It's called web part in Swav. It's called HTTP handler in Giraffe. It doesn't really Both implementations have some differences, but not enough to really go too deep into that right now. So we have this web part, which is a function, normal F# function, that takes HTTP context and returns asynchronously option of HTTP context. So it takes all the information that we can have, it performs some operation. If it succeeds, it returns some of the new HTTP context. If it's failure, it just returns none. And then we have this amazing rocket operator. No, it's rocket. I don't like fishes. I'm more like, science fiction guy, so definitely a rocket. This is like SpaceX operator. Yeah, it's detaching and landing totally, like, have you seen, by the way, there is this new font that basically is still a font but has animation included for some random reason. It's like new hype thingy in design community. So you could do a font with detaching. So the operator works really similarly to a bind operator in F#, to pipe operator in F#. It basically, or maybe to combine operator in F#, function combination. So it takes web part on the left, it takes web part on the right, and it combines them together, producing new web part. And what it does under the hood is it calculates when the request is incoming, it calculates the result of the first web part on the left. If it was successful, so if it returns some, then it pushes forward the context to the right web part. And yeah, joking aside, this operator has really serious name, but we won't do that on this conference. Those are like names for the Scala people. So yeah, example. Does it work? Oh yeah, amazing. So both Swav and Giraffe are coming with set of predefined HTTP handlers or web parts. So they are coming with some batteries included. And basically, most of the time you can divide web parts into two different kinds of web parts. One kind are the web parts that are doing some check. So they are doing if the HTTP verb, HTTP method of the request is as we want, if the path, URL path of the request is as we want, if request has particular header. And the second type of the web parts, HTTP handlers, are handlers that writes some responses to the HTTP response object that I've mentioned that's part of HTTP context. So here, in this example, really simple example, the first web part is called get. This is the web part that will check if our request have get HTTP method. If it has, it pushes HTTP context to, it doesn't mutate HTTP context at all. This is just like doing check. It pushes it to path web part, which will check if the URL is test. If it is test, then it will push HTTP context to this last web part. Last web part is text, and this is the web part that actually modifies HTTP response and puts some text into it, hello world. So that's one operator. And the another crucial thing about the model is the programming model is a choose function, and choose function takes list of web parts and combines them together into one web part. And it is actually doing it by iterating when request is coming. So when the request is coming into this choose goes to the first web part, this route ping. If it's successful, then it goes here. If this is successful, then it returns the result of this operation. If the route is not ping, it means that this returned none. This means that this whole block returned none. It means that it goes to the second line and tries to evaluate the next HTTP handler. And yeah, if route is slash, then it does something. So what it means in practice is that, first of all, it's all built on this abstraction of HTTP handlers. All those functions are using HTTP handlers or web parts, which means that we can easily compose them together. And if you think about that, using those two functions, so the SpaceX operator and the choose function, we can now model any decision tree that can happen in our web server. So our whole application can be modeled as one big choose. Then first check if it's GET request, then it goes to the next choose that do some checking. If it's post, then it do something. If it's route, no matter what verb, then do something. And if it's matching nothing, then it's returning some not found response. Which seems nice, which seems fairly simple, which seems fairly usable, and in my experience, it's really good. However, probably, it is really flexible and powerful model. Unfortunately, there are some problems. Probably if there were no problems with this model, I wouldn't be here talking about alternative solution in a moment. This model doesn't scales very well with the size of the application. So let's imagine typical REST-ish controller. Typical REST-ish controller have what, six different operations like patch, put, post on ID, whatever. There are a couple of those. Get on slash, get on ID. So imagine something like that. That's big chunk of code. And then imagine that you might have application that has 20 HTTP REST-ish controllers. That happens 30 REST-ish controllers, 50 REST-ish controllers, if this is really big API. This means that, well, you would need to write all those combinations together, those compositions, and this is starting to become boring manual work, and we don't want to do boring manual work. It is low level, so you need to make every decision on your own. It means that also that you need to really well understand HTTP protocol. So for example, setting correct headers on the response, setting, type header, content type header on the response. If you return JSON, you need to do a manual step, which means that you need to really, really well understand web programming in general. It doesn't provide any structure, and what I mean by that is that you can combine them together in whatever way you want, which initially seems like a good idea, but in practice it makes it really error prone. So it's pretty easy to really do something stupid and not really understand why you do something stupid, because you just mixed the order of composition that you should have in your application. And again, that probably requires really like going deep into understanding what's happening and what's going on in there. On the other hand, that was functional programming model. That was what we have in many functional programming languages. Such model, Suave, was not the first one that invented this model. Such model is used by the libraries in different programming languages, in different functional programming languages. On the other hand, we have our favorite OO world that we all love, and we have our favorite MVC pattern. And yeah, in MVC pattern, obviously, we have model, which is represented by some classes, probably with mutable stuff. Then we have view, and those are more classes. Well, it may be Razor, whatever Razor is compiled down to classes, it's classes. And then we have controller, yes, classes again. On the other hand, classes, you probably think that I don't like it, but there are a couple of advantages. So first of all, it is high-level model usually. So usually, like in ASP.NET MVC, you just create new controller, which is class, you implement a couple of methods, and routing is done automatically for you, for example, or you just put some attributes. They provide structure, So basically, they're like magical frameworks usually. You don't have ability to really do something wrong, at least in like low-level coding, because you don't have access to this low-level structure. You obviously can do something wrong in your own code. That happens to me pretty often. But yeah. And what's also a result of the structure, they provide additional tooling. It turns out that editor tooling, and probably, you know, if you follow me on Twitter or something like that, you know that I have this weird thing for editor tooling. And developer tooling in general. So it turns out that in practice, actually it's not like, usually F# and functional programming languages have worse developer tooling, but it turns out that it's not necessarily a result of being functional programming languages, but because they are not so structured in many ways. At least frameworks for those languages are not so structured. This means that in ASP.NET MVC you can do right-click create controller that will output for you controller, data model, migration, whatever. Same happens in Ruby on Rails. Yeah, and that's fun. There are disadvantages. The big disadvantage is, yeah, Juliana loves my talk. The big disadvantage is that they don't provide easy way to fall back to lower level programming model. In ASP.NET MVC it is possible, but it usually requires implementing some weird interfaces or overriding some weird classes that no one but ASP.NET Core team understands. So yeah, the question is, can we do better? And let's imagine ideal functional programming world. We have immutable model and set of pure functions that represents our operations on our model. Then we have a view function, and you probably heard about Fable, Elmish. So Fable and Elmish show us that view function can be pure function that takes model and just returns HTML. And controller is weird. It's not really a controller, but yeah, let's call it controller. The name is more fancy, like name of the pattern is more fancy if you use controller. Controller is a function that takes a set of pure functions and wrap them together. Wrap them together in particular structure, opinionated structure that provides all the features that usually MVC controllers provides in frameworks like Ruby on Rails, so routing and all this stuff, handling responses, handling content type headers and all this stuff. So yeah, so here we come to Saturn. Saturn is a web framework, and Thomas left. Thomas hates me when I speak about frameworks. Thomas has written a great blog post about library versus framework and why you should build libraries, not frameworks. I love Thomas, so I've decided to create framework. Because it's built on top of Giraffe, it integrates really well with existing ecosystem. And by existing ecosystem, I mean both Giraffe ecosystem, so existing Giraffe applications, but because Giraffe is built on top of ASP.NET Core, it also integrates well with all ASP.NET Core things that you can use. It provides tooling. I like tooling. So it provides stuff like create new controller, basically, that we will see in a moment. Well, tooling is work in progress. But yeah, there is some tooling. It provides a set of high-level abstractions that I will show you in a moment that will take care of the most common cases for you. So usually your work as a software developer is not to decide how to compose routing together in the web server. Usually your work is to actually solve the problem of your business. And building web server correctly and setting right content type is probably not your business problem usually. If it is, then just use Giraffe. And what's really, really interesting and what I find really unusual and unique across different web frameworks I've tried, Saturn provides really good integration and fallback to lower level programming model, because actually those higher level abstractions that I've mentioned and that I will show in a moment are not actually abstractions in understanding of, I don't know, OO programming, where those are different types or anything like that. I'm using a couple of really fringe F# features to transform my higher level abstractions into actually lower level code. So all my abstractions are transformed at the application startup, or rather at the compile time, to HTTP handlers, so to the stuff that I've been talking before when we've talked about Giraffe. And the last important part, it hides ugly parts of Giraffe. Giraffe is pretty okay with the fact that it sits on top of ASP.NET Core. The design of the Giraffe requires you to understand ASP.NET Core a bit, especially in terms of application configuration, injecting services, configuring dependency injection that is inside ASP.NET Core, and all this ugly stuff that Microsoft has done. So Giraffe doesn't try to hide it, doesn't try to change it. Saturn does try to hide it. Okay, and now it's demo times. There will be a couple of demos. I feel like a rock star, you know, those singers that first like have a mic on some stick, then go out. This is cool. Cool, okay. How this works. Okay, so first of all, before we move any further, as I've mentioned, OpenSaturn, OpenGiraffe, those two libraries are working perfectly well together. They are designed to work well together. Saturn is built on top of Giraffe, which means that, yeah, Saturn is using standard HTTP handler from Giraffe, which means that everything that's included in Giraffe, that you can use it also in Saturn. So, one thing I haven't mentioned. Saturn is using heavily computation expressions, F# computation expressions. People have really different opinions about what computation expressions should be about. If you go online and start reading some stuff, then you will see from some people, oh, computation expression is just like monadic do something syntax that just F# is like bad and just implements it incorrectly. But no, computation expressions are actually more fun. Computation expressions allows you to create custom operations inside of them, and that enables us to create custom DSLs really nicely, really nicely. So the first computation expression, and Saturn introduced 4 of them. So the first one is pipeline. Pipeline computation expression is basically working as our SpaceX operator, but in a bit different syntax. And on top of that, it also provides set of predefined high-level helpers. For example, must accept or accept JSON. I'm terrible at typing. That's not accept JSON. Whatever. Yeah, the description is actually from older version of the Saturn. I probably changed something and I don't remember. So yes, as you can see, there are this set header thing actually is it's not a normal function, because as you can see, it's inside of the computation expression. This is actually custom operations that provided by computation expression, which is really cool. And we provide really huge set of such functions, such custom operations, custom keywords in computation expression, so you don't really need to work so much as in the case of Giraffe, but this is still pretty low-level code. What is important, as you can see, using code lenses, this is actually HTTP handler. So I have something called pipeline. I'm doing some magic inside my pipeline, and this is actually transformed to HTTP handler. And HTTP handler is exactly the same thing that's been using by Giraffe, which means, okay, we can compose that with Giraffe. What is more important is that you can compose them together, because we have something called plug operation, and plug operation plugs into current pipeline any other HTTP handler, and our pipelines are accidentally HTTP handlers. So you can really, in declarative way, define your set of pipelines, or set of operations that you want to execute together, and then compose them together in any way you want. The second computation expression that we provide is called router. It was called scope in previous versions of the library, so if you've seen some documentation before, it may have been called scope. Nowadays it's called router. And router, as name suggests, it provides routing for your application. And by routing, I mean basically checking the HTTP methods and checking the paths. Why I have decided to do that? Because that's the most common way to route requests in your application. You probably sometimes have some more complex cases like checking headers or stuff like that, but in 90% of cases this is good enough. In case of Giraffe, the concept of like pipelines and those different operations and concept of routing is kind of like put together, because you can combine the HTTP handlers in whatever way you want. You can do whatever you want with them. I've decided to put them separately, to make them separate, just because in my view, and Saturn is pretty opinionated, in my view, those are two separate concerns that you should handle in two separate places in your code base. And of course, we have router, and we can pipe every request coming to this particular router into any HTTP handler, including our pipelines. And router again provides a couple of custom operations. So this pipe through, not found handler are custom operations, but also we provide like get, post, patch, put, head, and so on. Both in versions like just matching on the string, and the version that is using the formatting syntax, like printfn formatting syntax. So it means that you can have this type safe URL parsing, which is amazing. And I've stolen that from Giraffe. Like Giraffe also have printfn type of routing. What is important is that again you can compose routers together, because this get custom operations as last argument expects HTTP handler. Our routers are compiled down to HTTP handlers, as you can see in the code lenses, which means that we can really easily create subrouting mechanisms inside of our application, which is also really important, because usually if you create some component in your application, this component should only think about its own routing and not about routing of whole application. So you create small routers for a particular component, then you compose them together in nice declarative way. So far, those both computation expressions, pipeline and router, they're really nice and they provide some fancy syntax, but in principle they are doing exactly what Giraffe is doing, but with different syntax, and maybe some additional higher level helpers, but you could put those helpers inside of Giraffe and be done. The real core of the Saturn, in my opinion, is controller computation expression. And controller computation expression is a computation expression that models typical REST-ish controller. So it has a set of predefined actions: index, add, show, edit, create, update, delete, patch, something like that. And it creates routing, predefined routing table for you. So something like that, that you have get, request, and then get on the slash goes to index action, get on the add goes to add action, get on the particular ID should probably show particular element, and so on, so on, so on. This is following typical REST practices. Probably not all of them, because REST, people really believing in REST practices, I think they don't do nothing else but creating new REST practices. So yeah, so probably that's not REST if you follow all practices, but it's good enough. Yeah, and there's like list of there's a lot of those actions that you can implement, and there is convention that's saying that, oh, index action probably should render a list of the all items, or maybe just return them as a JSON, depending on whether you want to do server-side rendering controller or the JSON controller. We don't have any assumptions about that. You can do whatever you want, but there is kind of convention that, oh, we think that you should do that. On add, you should render a form. In add action, you should render a form for adding new item. And of course, all those are optional, so if you don't need some of them, then you can just ignore them. And that's how it looks in practice. So we have some code. We have also not found handler. And actually, we have a couple of more features that I will mention in a moment. And we have index, add, show, edit functions that are implementing something. And those implementations are simple F# functions working on HTTP context, which means they're really similar to HTTP handlers. Those are not actually HTTP handlers directly for some reasons, but they're kind of similar. You get, this is usually the place where, oh, this is last step in your endpoint, because this is the place where you actually display information, write information to the user. So usually having context is enough, because you got all the information through piping, through all the pipelines and routing, and now you're in the point where, oh, the magic happens. And your business code usually happens, that's magic. And of course, again, controller in code lenses, HTTP handler. This is amazing because it means that we have this high-level building block that we can easily compose with all other abstractions. It means that we can compose them with normal Giraffe applications, and so on, so on, so on. And that's what I've meant by when I was telling you that Saturn provides this really nice fallback to lower level mechanism, because since it compiles down everything to HTTP handlers, it means that you can, in one place you have the controller high-level building block, and in the other place you can have your really low-level HTTP handler implementation, and you can easily compose them both together, and there is absolutely no problems to do that. So this is really something unique as far as I can tell. And of course, yeah, HTTP handlers, they can be all combined together. We have routing, we have piping, we have forward, and we forward all requests to another router as a subrouting, and so on, so on, so on. And the last computation expression is application computation expression. And application computation expression, as I've mentioned, Saturn tries to hide some ugly bits of the Giraffe, and maybe rather ugly bits of ASP.NET Core, especially configuration. And what we do here is we provide set of high-level feature flags that basically tells you, oh, I want to enable memory cache in my application, or I want to enable zip conversion in my application, and just do that. And This is translated usually into quite a lot of configuration that's happening under the hood. This is pretty opinionated. Again, probably the aim of Saturn is not to be like perfect for everyone. It's the aim of Saturn is to be good for maybe 90% of use cases. And then if those use cases are not fulfilled by Saturn, you can always go to this lower level and just write stuff manually. That should work for you. Okay, how much time do I have? 15 minutes. That's amazing. And how do I do that? Controller abstraction in Saturn is more than just those couple of functions. It provides a couple of features that usually are not provided by the controllers. So first of all, it provides versioning. And versioning, there are like a couple of different ways to do versioning. They are all terrible. So what we've decided to do is do versioning based on the header, on the custom header, which is called xcontroller version. And basically, it enables you to create two controllers, two user controllers in this version. One is checking version, one is not. And then in our application, we forward request on the same URL. So if the request contains the xcontroller version header and it's equal to 1, then it will go to user controller version 1 and it will check that, oh, the header is there. It will execute actions from the user controller version 1. If not, it will go to user controller. So that's really nice. That's really powerful. That's another example of, oh, we are taking away decisions from you to make. Like, we are handling it in an opinionated way, but we are hoping that this will work well for you, so you as developers can focus on writing your business code, because that's what earn your company money, a lot of money. Second thing is subcontroller. So usually, if you have object model in like REST-ish controllers, you have some child items. For example, you can have blog post. You can have blog engine. So probably you have REST controllers representing all posts, and getting particular post is going to post/id. But then this particular post have some comments. So getting to the comments of this post usually should look like something like post/id/comments. And this thing in comments, the thing that's happening later, is actually another REST controller, usually. Again, this is usually in vast majority of cases if you are following REST principles. So that's what we have here. We have this user controller, and we plug subcontroller on comments endpoint. So, and we plug any HTTP handler. Because we can plug an HTTP handler, obviously we've chosen to plug a comment controller this time. So this will create routing like I've mentioned, user/id/comments, and then all the requests that goes to this user/id/comments will be forwarded to this controller, and this controller will behave like a normal controller just on this subroute that was passed. The third important thing is the functionality we call plug. And plug enables us to do some particular actions for some additional actions for particular actions in the controller. So for example, just for index and show. Why we do that? Because, for example, in controller, it's pretty often that you have some public data, so everyone can display data, so everyone can access index or maybe show actions. But for updating the data or changing the data, creating new data, you maybe want to authorize controller or check if he has right privileges to do so. In ASP.NET MVC, this is usually done by the magical attributes and stuff like that. We don't like attributes a lot as a functional programming developers, I think, and as F# developers. So instead, we've created this model based on the normal pure functions that actually behaves like that. Okay, and the tooling sample. As I've mentioned, let me check that, change that. This is it. Okay, as I've mentioned, one of the aims for the Saturn is also to create the tooling around the whole thing to make it super friendly to, especially to new developers coming to the project, so they know how to behave, what to expect, and how to get up to speed as fast as possible because they want to get to their business problems as fast as possible. So this is created application using .NET New template that Saturn provides, .NET New Saturn. I won't show creating of it because like earlier today internet was failing, so yeah, I have it ready and let's not try this again. Yeah, let me check that. So .NET New Saturn creates a solution with the packet and fake, all the stuff that we love as a F# developers, and then it has solution file containing two projects. First one is your project where you will coding. It will create some helper functions, some helper files with some helper functions. We don't really need to go too deep into that. It creates something called templates folder, and templates folder contains default views. You know, if you create a new ASP.NET MVC application, you also have this nice default view with nice UI showing how cool are people from Microsoft. So yeah, so we have something called layout, which provides like general layout of your application, like menu and head and menu in a body and so on. Load the JS scripts, and then we have index page, which is default page, not found page, which is something that gets executed when we go to URL that doesn't exist, and internal error page that displays some information if you throw exception like message, source, stack trace. So you have this like nice view in the browser, just like in ASP.NET MVC. And maybe let me try to start this. This is, yeah, it creates build CMD and build SH files with predefined fake scripts that will clean, build everything, and it works. So we have this beautiful page. This is this index page default. It's lovely. I know my design skills are so amazing. And then if we go to some random URL, we have this error 404 page. Again, this is great example of design skills. Yeah, thanks. I know you love it. But that's the first part of the tooling. As I've mentioned, we also have something that will enable us to create new controllers. So let me open terminal. So I've opened terminal in the Visual Studio Code. I will go to the subdirectory with the Saturn project, and then do something called .NET Saturn. And we'll do help. There are a couple of commands. There is some help. There are a couple of available commands. I won't go into all of them because we don't have time for that. But let's just use the first default one. So .NET Saturn again. And let's generate some random book controller. So we give it a name of the controller, the name of the namespace, and then some fields. And right now, this tooling is only command line tooling, but you know, command line tooling is you can easily write UI tooling on top of command line tooling, which means that we can pretty easily create the Visual Studio Code extension for that, or like Visual Studio if someone likes that. Don't, please. So we create few fields. We execute that, and let's quickly look at that. First of all, it tells us that it generated a couple of files. Secondly, it tells us that it updated the FS project file, and actually you can see that it's actually happened. Here there is books folder with model views, repository controller. Also, what's interesting that we will move in a moment, it also generated something called migration file and updated migration project. But what's the first thing? Controller generated. You need to add a new controller to one of your routers in routerfs. Okay, let's do that if you tell me so. Like the guy who has written it must know something if he tells me to do that. Let's go to routerfs. Let's put it in the random place. Let's save the file. Whoops, that's not what I was willing to show you. Let's run application again. It will build in a moment. Theoretically, I could probably keep watch mode running, but yeah, there are some errors. Oh, yeah, small mistake, because there is the version of generator was not updated to recent version of the Saturn. There was like one small change. Okay, this is running. This means we can do this. And now we can go to /books because that's what we've done in our routing. Huh, that's not what we've done in our routing? Have I made typo? Please tell me that I've made a typo. Forward books. Oh, maybe this is wrong place. Yeah, this is good place. Sorry for that. Demo goats are. This is working. This is reloading, starting application. Yeah, it's here. We go to books. Oh, no such table books. So as you can see, it tried to connect to some database. It failed. That makes sense, probably because we actually haven't run the migrations that it created for us. So let's check migrations project. Migration project is using a C# library called Simple Migration. Simple migrations. It basically models migration of the database as a classes, as a types that need to inherit from migration, and you override two methods. What's happening when you go up to given migration and what happens when you go down from given migration. And Saturn tooling is generating this stuff for us. So now we need to do .NET Saturn migration. Execute. This takes a moment. By default, template is using local SQLite file just for sake of convenience and playing with that. You can easily connect it to any other database you are willing to. However, the generated migration and the generated queries are probably using SQLite syntax. So I mean, especially types. Different SQL databases have different stuff in there. So this probably will require some changes, but not much. And now we have view that is listing books because we are on the get on the / in the books controller. If we go to new book, which will move us to books/add, we have form for adding new stuff, and we can do what we can do. Title, expert, F# done. Yes, and it's in the table. So as you can see, this UI is pretty rough. It's nothing fancy, but it's in there. So you have this structure to start developing your application. Edit, delete, and so on. And let me start finishing the talk. So what's next for the giraffe? I want to introduce something called channels, which would be abstraction on top of WebSocket communication, like real-time communication. I want to focus on testing. for those of you who like follow me on GitHub or like check some of my projects on GitHub, you may know that I usually don't have a lot of tests in my projects on GitHub. And I hope that this one will have a lot of testing. But also I want to focus on testing from the user point of view, so provide like library that will extend maybe NUnit or maybe Expecto or maybe XUnit to provide them easy way to test their own applications and their own controllers, their own pipelines, so they can do whatever they want pretty easily. They can test pretty easily. I want to work on the diagnostics, like real-time diagnostics when you're running application, to that you can easily go into your application and see what's happening inside. And I want to have deeper integration with Fable because Fable is cool. Saturn is part of SafeStack. If you haven't heard about SafeStack, SafeStack is an initiative that puts together a couple of F# technologies that work really, really well together. Saturn, Azure, Fable, and Elmish to create this end-to-end functional first F# experience in the web programming. And yes, do you have any questions? Any questions? Anyone? Oh my God, that was so terrible that you don't have any questions.
2 minutes.
2 minutes for questions. Yes, please.
For the simple tables having just little fields in a form generation like ID name, it's good, but most databases you're doing joins and foreign keys and stuff like that.
Yes, that's something that will. So the question is that, oh, I've shown the example of really simple, this code generation thingy was really simple because that was like 3 fields and just plain type. And actually I've used only strings because anything else than string may fail. So I haven't told you that.
Any thoughts on how you make
Yeah.
stuff like that?
Yeah, I hope that we can do that. Tooling is something that's in my mind, but it's not been my development time focus right now. So I have it in my mind. I know that I want to build a lot of good tooling around Saturn, but right now I've been more focusing on just plain framework functionality and framework design. Okay, we don't have time for any more questions. So my name is Chris. You can find me on Twitter, on GitHub, on 500px if you like photography. I have blog, I have company. Thank you.
Please remember to talk to that.
Yeah, only green cards, please. You know, I can do more stupid jokes about good things about in US, like public transport. Healthcare, no. Like, I cannot use the same. This is what is difficult about doing multiple talks on the same conference. I cannot use the same jokes. I need to come with new ones.